Can Mars be our future home? It's a question that has sparked the imagination of scientists, researchers, and even sci-fi enthusiasts for years. The red planet, the fourth celestial body from the Sun and the second smallest planet in our solar system, has been the focus of countless studies, research projects, and space missions. Mars, with its thin atmosphere and surface features reminiscent of the impact craters of the Moon and the valleys, deserts, and polar ice caps of Earth, has always intrigued us. Over the years, the curiosity surrounding Mars has grown into a serious consideration. Could it be possible? Could Mars, this terrestrial planet that's so different yet so similar to our own, become a future home for humanity? It's a possibility that's as intriguing as it is challenging. Mars holds many resources that could potentially support human life. Its icy poles hold water, a crucial element for human survival. The planet's atmosphere, although thin, contains carbon dioxide, and there's nitrogen in the Martian soil. These resources could, in theory, be used to support human life. But it's not just the potential resources that make Mars an intriguing possibility. Mars is relatively close to Earth, at least in astronomical terms. This proximity could make travel to and from the planet more feasible. There's also the scientific potential. Mars is still a planet of mystery, a world that we're only just beginning to understand. Colonizing Mars could open up new avenues for scientific discovery and understanding. And then there's the human factor. The idea of expanding our reach beyond Earth, of setting foot on another planet, is a testament to our spirit of exploration and discovery. It's a step forward, a leap into the unknown that could redefine what it means to be human. It's a tantalizing possibility, but what are the challenges we would face in making this a reality? Living on Mars isn't as simple as packing up a spaceship and launching off. There are significant hurdles we need to overcome. The first challenge is Mars's thin atmosphere. This isn't just about having enough air to breathe. Mars's atmosphere is about 100 times thinner than Earth's. This means it doesn't provide much protection from solar radiation, and it doesn't hold in heat. Imagine trying to breathe at the top of Mount Everest. That's how thin the atmosphere is on Mars. Additionally, it's mostly carbon dioxide, which humans can't breathe. So we'd need to find a way to either make the existing atmosphere breathable or create a controlled environment where humans can live. The second challenge is the cold temperatures. Mars is much further from the Sun than Earth is, so it gets a lot less heat. The average temperature is minus 80 degrees Fahrenheit. That's colder than the coldest temperature ever recorded on Earth. We'd need to find a way to keep warm, whether that's through clothing, habitat design, or some other method. The third challenge is radiation. Mars's thin atmosphere and lack of magnetic field mean that a lot more solar radiation gets to the surface than on Earth. This radiation can damage human cells and DNA, increasing the risk of cancer and other diseases. We'd need to find a way to shield ourselves from this radiation, either by building underground or developing new materials or technologies. The final challenge we'll discuss today is the lack of food and water. While Mars does have water ice, it's mostly in the polar ice caps and underground. Extracting it and making it usable for humans would be a significant challenge. As for food, bringing enough from Earth to feed a colony would be hugely expensive and impractical. We'd need to find a way to grow food on Mars, which would require overcoming the previous challenges of atmosphere, temperature, and radiation. These challenges are daunting, but they're not insurmountable. Let's explore the potential solutions. While the challenges are significant, human ingenuity and technological advancements could potentially address them. This statement rings true, especially when we look at our history of overcoming barriers and pushing beyond our known limits. So let's take a moment to delve into how we could solve some of the challenges presented by the red planet. To begin with, the thin atmosphere of Mars, primarily composed of carbon dioxide, is a significant hurdle. However, through an ambitious process known as terraforming, we could theoretically thicken this atmosphere. The concept involves releasing gases from the planet's surface to create a greenhouse effect, warming Mars and possibly making it more habitable for humans. Next, we tackle the biting cold of Mars. Here, terraforming could also play a role. By thickening the atmosphere, we could trap more heat, potentially raising the planet's average temperature. Furthermore, technology could aid in developing habitats with controlled climates, much like how we manage temperature in our homes on Earth. The threat of radiation on Mars is another serious concern. Mars's thin atmosphere and lack of magnetic field mean that harmful cosmic rays reach the planet's surface unfiltered. However, we're exploring solutions such as radiation shielding materials for habitats and suits, as well as potential medicines that could help our bodies better resist radiation damage. Of course, we can't forget about the basic necessities of life: food and water. Mars's soil contains water ice, and with heat this can be turned into liquid water. As for food, we could utilize hydroponics and other forms of agriculture tailored for Martian conditions. In situ resource utilization, or living off the land, would be crucial to sustain a human presence on Mars. But necessity is the mother of invention, as the saying goes. And these challenges, while daunting, drive us to innovate, pushing the boundaries of what we deem possible. These solutions are within our technological grasp, but what about the benefits? Why go through all this trouble? Well, the exploration of Mars could bring about advancements in numerous fields, from space travel to resource management, which could have far-reaching implications for life on Earth and beyond. The challenges are tough, but the potential benefits of colonizing Mars could be monumental. Imagine a world where resources are abundant, waiting to be tapped. Mars, our neighboring red planet, possesses a wealth of resources that could support human life. From water ice, which can be converted to liquid water, to carbon dioxide and nitrogen essential for plant growth and oxygen production, Mars presents a promising prospect for resource utilization. But the benefits don't stop at sustenance. Mars is a goldmine of scientific discovery. Its geology and climate bear striking resemblances to Earth's, yet its unique characteristics, such as the largest volcano and deepest, longest canyon in the solar system, offer a new frontier for scientific exploration. The possibility of discovering past or present life on Mars could revolutionize our understanding of the universe and our place in it. Moreover, colonizing Mars would symbolize a significant leap for humanity. It would mean we have become a multi-planetary species, a concept that might sound like science fiction today, but could be our reality in the not-so-distant future. It's not just about survival or resource acquisition, it's about the evolution of humanity and our ceaseless quest for knowledge and exploration. Imagine the inspiration that the first step on Mars will provide to future generations. Just as the moon landing in 1969 ignited a generation of imaginations and spurred technological advancements, a Mars colonization could do the same, but on an even grander scale. Yet, there's an even more profound implication of becoming an interplanetary species. Mars colonization could serve as a backup plan for humanity, ensuring our survival should Earth become uninhabitable due to natural or man-made catastrophes. The benefits are enticing, but the question remains, can Mars be our future home? This is a question that will continue to spark debate, ignite imaginations, and drive scientific and technological advancements. It's a question that challenges us to dream bigger, strive harder, and push the boundaries of what's possible. So, can Mars be our potential future haven? It's a question that opens up a universe of possibilities, yet no definitive answer. Today, we're diving much deeper into the tantalizing opportunity of transforming Mars into our future settlement, scrutinizing not just the variety of obstacles that Mars colonization poses, but also an extensive exploration into the prospective rewards. On one side of the coin, we have to tackle a series of considerable challenges. We are faced with the need to thicken Mars's thin atmosphere, construct a sustainable system to moderate the planet's icy temperatures, develop robust radiation shielding for human inhabitants, and establish secured supplies of food and water. Moreover, we need to consider the potential for spaceborne illnesses and the psychological impact of living on a new planet. All of these demand massive technological advancements and innovative solutions. Yet on the flip side is the potential payoff. Beyond the abundant resources that Mars could provide to sustain human life, its proximity to Earth makes it a feasible option for colonization. The planet offers a vast canvas for scientific exploration and discovery, promising advancements in various fields like astronomy, geology, biology, and potentially even the discovery of extraterrestrial life. Furthermore, the opportunity to establish a human settlement on Mars could have profound implications for human evolution. Living in this radically different environment might lead to physical and genetic adaptations, driving our species into a new evolutionary path. Finally, the act of colonizing Mars would be a spectacular stride for humanity. It would thrust us headfirst into a new age of space exploration and discovery, pushing the boundaries of what we believe is humanly. It's an intricate puzzle, with pieces that are both daunting and exciting. But the potential rewards, from technological leaps to evolutionary shifts, could be nothing short of monumental. What are your thoughts on the prospects and challenges of Mars colonization?